Welcome students, welcome to the thermal engineering session. Last class we saw about the conduction of heat transfer through a composite wall. This is also one more example of the conduction of heat transfer through composite wall. Let's check the question. A flat wall is composed of 0.2 meter thick fire clay bricks faced with 0.1 meter thick insulation. So there are two layers. One layer is fire clay bricks and the other layer is thick insulation. Determine the heat flow rate per unit area of composite wall. So first we have to determine the heat flow rate per unit area of composite wall and interface temperature. Interface temperature is the middle temperature between two walls. Assume coefficient of thermal conductivity for fire clay brick and insulation as 1.039 watt per meter Kelvin and 0.278 watt per meter Kelvin respectively. Assume outer face temperature of fire clay wall be 870 degrees Celsius while outer phase of insulation be 210 degrees Celsius. Okay. Now, before going to the solution part, let's draw the diagram. Okay, this one is fire clay brick and this one is insulation. Okay, so what is happening here? Here inside here only the fire is happening. It's inside the okay. So inside this, the temperature is maintained at T1 and the outer wall temperature is T3 and the middle temperature is T2. Okay, so therefore T1, T2, T3. The heat is transferred from here and to till T2 and T2 and then out. Okay, so what is the temperature is maintained here? The T1 temperature, the given value. T1 temperature is maintained at 870 degrees Celsius and the T3, the outer temperature is maintained at 210 degrees Celsius. Okay, then what about the thickness? Let us consider as thickness is L1, brick thickness is L1, insulation thickness is L2 and the fire clay brick conductivity value is K1 and insulation conductivity value is K2. Therefore, K1 value is here 1.039 watt per meter Kelvin. K2 value will be 0.278 watt per meter Kelvin. What is the thickness value here? That is L1 is equal to 0.2 meter and L2 which is equal to 0.1 meter. Okay. Now what we are going to find? First one is heat flow rate, that is Q value. Second one is this interface temperature, that is between T1 and T2, T1 and T3. This between two walls, the fire clay brick and insulation brick inside middle one. This temperature you have to find. Now we are going to find the solution. First thing, we are going to find the heat flow rate, that is Q1 to Q2. The formula is, now we are going to check the heat flow rate for the whole system, that is T1 minus T3 divided by L1 by K1 A1 plus L2 by K2 A2. Okay, these two areas are area will be, since the area will be common, this is this phase area. This phase area will be common to both the things. So take it common as outside and bring it this side. So that we'll get Q of 1 to 3, Q of 1 to 3 divided by A, which is equal to T1 minus T3 divided by L1 by K1 plus L2 by K2. What is T1? 870 degrees Celsius minus 210 degrees Celsius divided by L1 is 0.2 divided by 1.039 plus 0.1 divided by 0.278. The answer will be 1195.20 watt per meter square. So this is the heat transfer heat flow rate. The same heat flow rate will be equal from 1 to 2. The same heat will flow from heat from 1 to 2 and from the 2 to 3 point. So now we are going to see about find out the interface temperature. To find interface temperature T2, use the formula Q1, the same formula Q of 1 to 2, which is equal to T1 minus T2 divided by L1 by K1 A1. Now we are going to check only this area, this brick only, that is T1 and T2. Okay, the Q will be same. This is only this area only we are going to check it. Okay, bring this A here. Q1 by 2, which is equal to we know that this Q of 1 to 3 by A, which is equal to Q of 1 to 2 by A, which is also equal to Q of 2 to 3 divided by A. The same, all heat flow rate will be equal only. And equal, that value also equal to 115.20 watt per meter square. So now put 1195.20, which is equal to, simply put T1 minus T2 divide by what is the value of LA1 comes. What is the value of L1? L1 is 0.1 divided by 1.039. Okay, so T2, we know that T1 minus T1 minus T2, which is equal to 1195.20 into, bring this into multiplication, 0.2 divided by 1.039. So that we will get it. And in the same substitute, T1 is equal to, what is the value of T1? You substitute 870 degrees Celsius. So finally you will get T2 is equal to 639.93 degrees Celsius. And one more thing you have to check it, that this T2 value is always between the T1 and T3. This T2 value is always between the T1 temperature and T3 temperature, that is 870 and 210 degrees Celsius. Whether if it is beyond the value means check it whether your problem is right or wrong, whether your any calculation is right or wrong. Thank you.